MS Ramaya University of Applied Sciences.
Hi students, let us discuss the permeability of molding sand through permeability number. Theory behind this experiment. What is permeability? It is the property of sand which permits the steam and other gases to pass through the sand mold. This is called permeability. It is determined by measuring the quantity of air that passes through a given sample of sand in a prescribed time and under standard condition. The permeability of sand depends upon its grain size, grain shape, moisture and clay components of the molding sand. Low permeability will lead to a smooth casting surface finish but also could cause blows, pinholes and expansion defects. High permeability reduces gas pressure but can result in mechanical penetration and a rough surface finish. Why permeability is important? When liquid metal is poured into the sand mold, heat from liquid metal produces enormous gas by burning clay or resin present in the mold. This gas has to go out to the mold wall. Hence, mold should have required porous channel for gas to flow out. Permeability comes from sand particle size, shape, mold ramming, moisture content and amount of binder present. Coarse round sand gives high permeability but low strength, but fine angular sand gives low permeability but high strength. Since both properties are important, we have to optimize. How to determine permeability? To determine permeability, the AFS standard sand specimen of 5.08 cm diameter and 5.08 cm in height is prepared by ramming the required quantity of sand in a smooth surface tube with 3 blows of standard rammer. This sand specimen is placed in the mercury cup of the permeability meter. The air drum is raised to take 2000 cm cube of air into the air drum, which will be indicated by the graduation on it. The whole air is then allowed to escape through the sand specimen with a pressure of about 10 gram per cc and the time is recorded. Test procedure. Screw big orifice with washer on the rubber sealing boss and tighten the orifice. Keeping OPD valve in D position and uplift the air tank. Adjust manometer to 0 position by padding or releasing water. Final 0 level is adjusted by opening 0 edges screw provided in front of manometer tank. Take specimen tube with rammed specimen and place it inverted over the rubber sealing boss. Put the valve in P position. Read the height of the water column in the manometer tube. Find out corresponding permeability number from the chart fixed on the instrument. This number represents the permeability property of the mold in use. Result. Permeability number indicates capability of mold to send out generated gas. We have to optimize this to ensure good permeability and strength.
Hi students, let us determine the permeability number of the green sand. The apparatus required are sand permeability tester. This is the sand permeability tester, measuring drum, measuring chart, manometer, large orifice, drum position lever. This is a sand rammer which has got ramming cam, lifting cam, plunger, sliding weight, plunger rod, scale. pedestal cap, specimen tube. This is green sand which is weighed of 150 grams, which contains silica sand, bentonite and water. Let us start the experiment. The weighed 150 grams of green sand is filled in the specimen tube, and the entire setup is placed for ramming on the sand rammer. Release the lifting cam, and the ramming cam has to be operated for 3 times. And see, the plunger rod has reached the mark of 0 to get the standard sample size of 50 mm dia and 50 mm length. Operate the lifting cam and take out the specimen tube and separate the plunger cap. Do not remove the sample from the sample tube, and with the inverted position, place it on the large orifice position. To start the experiment, ensure that manometer reading is 0. Presently, the measuring drum position in O. Slowly change it to P position, which will give the permeability number of the green sand. Now the drum is descending. Now we have to see the manometer reading 2.4, and we have to see in the chart, we got the manometer reading as 2.4. In the chart 2.4, we have to horizontally move to the large orifice, which gives the number 358. This is the permeability number of the green sand sample. This completes the experiment of the permeability number of the green sand.
At MSR UAS, we spark your imagination unlike any other.